Example questions.
Okay, now have a look at this example. Okay, we have a diode is switched on, it has an operating voltage of 0.7 volt. Okay, it connects to series with a 200 ohm resistor, okay, and a 6.5 volt power supply. Okay, so the diode is connected, uh, it's forward biased. Okay, question A: what is forward biased? Okay, now forward biased basically means the diodes allows the current flow from the positive to negative. Okay, so just write it down in words. Now let's look at question B. Okay, we need to find the current. Okay, before we do the question, let's always sketch the circuit diagram. Okay, so I have a 6.5 volt power supply. So okay, the question should be clear. It should be should be a DC power supply. So let's write down the battery. Okay, so 6.5 volt. Okay, now it's forward biased. So uh, yeah, the diode is going to, yeah, it's going to be in this direction, okay, because it's forward biased. Okay, it's connected in series with a 200 ohms resistor. Okay, then yeah, that's it. Okay, now we need to find the current. Okay, now, since this is a series resistor circuit, the current is the same. Okay, now we have 6.5 volt here. Okay, the operating voltage of the diode will be 0.7. Okay, so the voltage across this resistor, okay, the resistor uses the rest of the voltage. Okay, will be 6.5 take away 0.7, should be 5.8, okay, volt. So I know the value of resistance. Now I know the value of resistor. Sorry, I know the voltage across the resistor. Use Ohm's law, V equals to IR. So the voltage, yep, put all the values in, 200. The current will be um, 2, 0.0, sorry, 0.029 amps. Okay, now the important thing when doing this question is, okay, because we have a diode. Okay, normally in year 11, uh, when we talked about finding current, okay, we always try to find the total resistance. Okay, then we use the equation V equals to IR to find the total current. Okay, but in this case, the diode is a non-ohmic device. Okay, we cannot find the resistance of the diode. Okay, so what we're going to do is basically we're going to analyze only this section of the circuit. Okay, we find the voltage of the diode, the operating voltage, so we know the voltage across the resistance. Okay, then from those informations, okay, we, we find the current. So we cannot find the total resistance or the equivalent resistance in this case. Cannot find because the value of the resistance of the diode is unknown. Okay. Of course, with the current we can do it, but it's a non-ohmic device. Okay, the voltage, the resistance of the diode changes. It always changes. Okay. Okay, now have a look at this question. Okay, so we have the same diode, we have the same resistance, we have the same circuit, okay, and the diode is connected in reversed biased. Okay, so question A asks me to reversed biased. Okay, so reversed biased basically means, uh, yeah, sorry, reverse, reverse biased basically means, uh, well, the diode is set up to uh, to make to make current flow in a reverse direction. That is from the negative, only allows current those who flows from the negative to the positive, to the reverse direction. Uh, so let's write it down. Okay. Now, question B ask me for the potential difference, means the voltage across the diode. Okay, well, it's actually we call this this time we call it the potential difference. It means the voltage. Okay, so anyway, okay, step one, we need to sketch the diagram. Okay, so again, okay, I have a 6.5 volt battery. Okay, it's a DC supply. Now this time the diode is in reversed direction, so we sketch it in a reversed direction. Okay, then it connects with a resistor of 200 ohms. Okay, then we close the circuit by yep by doing this. Okay, so what's happening is now this time I need to find the potential difference, the difference in voltage before and after the diode. Okay. Now in year 11 we didn't do well. In year 11, okay, we always treat potential difference as the voltage across. It's the same thing, but now have a look this case here. Okay. Now if you can tell me what is the potential difference, sorry, what is the voltage, okay, on the left hand side of the diode. Okay, so I have a positive here, 6.5 volt, and basically on the minus side should be here. Terminal of the battery is 0 volt. Okay, so the voltage on the left hand side of the diode will be 6.5. Okay, will be 6.5 volt. Okay. However, on the right hand side of the diode, because the current is not allowed to uh, travel through the diode now. Okay, so the voltage on the right hand side will be 0 volt. Okay, similar to here because the current is forbidden to travel through, travel against the direction of the diode. Okay, so I have so the potential difference will be the difference between the right hand side and the left hand side of the diode. Okay, so the potential difference of the voltage across the diode this time will be 0.5 volt. Okay, because yep, this is what's happened here. Okay, the current will be 0 because the current is not allowed to travel through it, so the current will be 0. Okay, yeah. Yep. Okay, done. Okay. Now please look at this question. Okay, so what we have is we have a circuit. Okay, and there are two resistors. Okay, one is 1000 ohms, the other one will be a temperature sensor. Okay, so what we need to do is we need to find the current when the air temperature is 20 degrees. Okay, and here is the graph, okay, for the temperature sensor. So yep, let's have a look. Okay, so the first thing we need to know is, okay, we need to know the resistance. Okay, we need to know the resistance of the temperature sensor. Okay, so we know it's 20 degrees. We read through the graph. The resistance will be 2000 ohms. Okay, now we have the complete circuit. So we need to find the current. Okay, we know, okay, V equals to IR. We know the total voltage, okay, which is 6.6 volt. Okay, we need to find the total current because the current doesn't change. It's a series circuit. Okay, so the current should be the same, and the resistance. Okay, now we need to find the total resistance, the equivalent resistance. Okay, so in series circuit, the equivalent resistance will be just adding them up. So 1000 plus 2000, which is 3000 ohms. Okay, put your equation in. V equals to IR. I equals to V divided by R. Put all the values in. Okay, the current will be 0.006 amps. Okay, but our answer needs to be in milliamps, so it's going to be 6 milliamps. Okay, so